Okay, so we're doing a video here for a problem in chapter 15, problem 15.5, and it's a good example of why I wait on chapter 14 until we get to things later. But we do have to review now the things that we learned in chapter 14, or didn't learn, right? We saved them for now. That said, you could do this without chapter 14, but to understand what the question is asking about and see where that kind of wording comes from, I'm going to refer back to chapter 14. Okay, so this problem starts out by saying, suppose you have a wave function, psi. And this is language we've been using a bit. By the way, I do think I'm going to divide this video up into the separate parts for the question itself, okay? So we've got this psi, which is a sum of wave functions, okay? This is a concept that shows up on page 338 in chapter 14. Although, again, if you're okay with the fact that we've just got some function and it's a collection of other functions, then that's okay. That's no problem. We've done that before. For example, f of x is equal to 3x squared plus x plus 4. Well, that's a sum of other functions, right? We might say that g of x was equal to 3x squared. H of x is equal to x, and what comes next after h? I don't know. K of x is equal to 4, right? And so we could have said that f of x was equal to that plus that plus that. Shoot, we could have even said f of x is equal to, let's say g of x is just x squared. Then that would be 3g of x, right? Plus h of x plus 4, or rather, plus k of x. Okay? So that's okay. I mean, mathematically, we can deal with a function being a collection of other functions, or the sum of other functions. Well, it turns out in quantum mechanics, we're going to call this the superposition of functions. I'm not sure we need such a big name for it, but maybe if we use it a bunch of times, it won't seem like a big deal. Okay, so that's on page 338. I do recommend after you do this problem that you go back and read page 338. I think it'll make a lot more sense now than it would have had we done that sequentially. Okay, so we've got this function psi, which in the pages below, or in the work below, I think I'm just going to call it psi, is equal to 3/4 phi1. I'm not going to remind you that it's a function of x, or that's a function of x, right? Plus root 3, 2 over root 2, phi2, and so on. Okay? So, the first, by the way, sorry, still in the question stem is this, that phi1, phi2, and phi3 are orthonormal eigenfunctions of the operator e hat with the e1, e2, e1, and 4e1 being the eigen values of these, respectively. Okay? So, as we knew, we're going to be using these terms over and over again. So it's a great time to review. If you feel like you're behind on chapters 12 and 13, and even 15, shoot, this is the time to do it. Give problem 15.5 your heart and soul, and you'll review a ton of things. It's a great problem to do. So I'm glad a student wrote and asked about it. Okay, so for part A was to verify that psi is normalized. Now, in order to do this is nothing but a chapter 13 problem. In my opinion, there's nothing else we have to know from chapter 14 or anything. Just verify that it's normalized. When I see something like that, the first thing I'm going to do is I'm going to remind myself, what is the definition of normality? Of a normal function, right? It is psi star psi dx is equal to 1. And that's it. Right? So I'm going to take this function, and this is going to be a little bit long, but I think in the end we're going to go, oh, that was not such a long problem. I'm going to go the long way because any solutions guide can go the short way, right? So let's go the long way just in case you've got questions on it. Of course, you can fast forward or skip parts that you think are a waste of your time. That's the nice thing about this. Okay, so what I'm going to do is I'm going to start out with this psi star psi dx is equal to 1. That's my definition of normal. And so I'm going to say, again, psi is equal to root 3 over 4 phi1 plus root 3 over 2 root 2 phi2 plus 2 plus root 3I over 4 phi 3. Okay? So psi star then, I'm writing all this out so I don't make any mistakes. Some of you might, well, please don't do this in your head. Plus root 3 over 2 root 2 phi 2 plus 2 minus root 3I over 4. That's the only difference between psi and psi star, right? Okay, so the first thing I'm going to do when I do this, if I'm not thinking super clearly, I'm going to go the long way, and I'm going to write all of this out. So the integral of root 3, 4 psi 1, plus, I'm going to put this in parentheses and multiply them, right? Root 3, rather 2 root 2 phi 2, plus 2 plus 3I, root 3I over 4 phi 3, right? Psi star is supposed to go first. It doesn't really matter. It's going to be the same thing, but I'll change it to a minus there. Psi star is minus. Okay? So it's root 3 over 4. I'm getting somewhere here, folks. Bear with me. Root 3 over 2 root 2 phi 2 plus 2 plus root 3I over 4. And as I was thinking about phi 3, as I was thinking about is equal to 1, right? Doing this video, I'm making notes to myself and making sure I thought through everything. Where's my notes? And I did a problem out. I was going to show you all of my notes I made for it. Okay. What you can do, I don't see it right here. What you can do is you can multiply, obviously we just got a bunch of integrals to do, right? So I'm going to take these two terms and multiply them out. And that'll be term 1. Term 1 is root 3 times root 3 is 3 over 4 times 4 is 16. Right? Phi 1 squared. Right? Now here's where the ortho and the normal is going to save you just tons of time. I mean, the whole semester really is about simplifying really complicated scenarios so that we can get to meaningful answers. And what does ortho and normal mean? Ortho means that these functions with respect to each other are orthogonal. Okay? So my phi 1 and phi 2 term are going to go to 0 when I do that integral. Right? This is going to be the integral of a bunch of things. Right? That plus that plus that. And I can separate these out because that's what you can do with integrals. But when I have an integral, when my second term is here, that's number 2. This is number 1. Number 2 is going to give me some hairball times phi 1, phi 2. Well, that's going to go to 0 because they're orthogonal. Boom, 0. Okay, now I can save myself a ton of time. So any phi 1 times phi 2 is going to be 0 times phi 3 is going to be 0. So it's 0. So phi 2 times phi 1 is going to be 0, but these two, right? So that's going to be, I'm going to say this is term 3. And term 3 is going to be root 3 times root 3 is 3. 2 root 2 times 2 root 2 is 4 times 2, right? Phi sub 2 squared. Okay? And that's term 3. And term 4 then is going to be, boom. Right? There was all the other terms that had the cross functions in them went to 0. So it's just this squared, and that squared are the only ones that are not going to go to 0. So that's going to give me, all right, I can't do this in my head. 2 plus root 3i, 2 minus root 3i over 4 times 4, which is 16. And that's going to be psi sub 3 squared. All of this mess, dx is equal to 1. And that's my job for this. I put 1 here. I was going to do that. But that's my job for this question, part A, is to show that this is normalized. So if this is true, I'm golden. Okay? So, let me write, I'm going to simplify this. This is 3/16 phi1 squared plus 3/8 phi2 squared plus, gosh, I can't do that on my head. Let's go to another sheet of paper. What is that? 2 plus root 3I over 4. 2 minus root 3I over 4. 4 minus 2 root 3I. Okay, I can remember now. Plus 2 root 3I. These two terms cross off. Minus 3I squared over 16, which that becomes 4 minus 3 times 1, right? Over 16, which goes to 7/16. Okay. So 7/16 psi 3 squared, right? Dx is equal to 1. Okay. Now, this then becomes 3/16 phi 1 dx plus 3/8 phi sub 2 squared dx plus 7/16 phi 3 squared dx is equal to 1. All right, this then, we pull the 3/16 out. 3/16 phi 1 squared dx plus 3/8 phi sub 2 squared dx plus 7/16 phi 3 squared dx is equal to 1. All right, now, since this is now it's in time, so we got rid of phi 1, phi 2 terms. They went to 0 because of orthogonality. Okay? But phi 1 terms, or phi 1 squared terms, that is going to equal 1 because of normality. Okay? These are normalized. Because the question stem said they're orthonormal. Right? So, since they're normalized, then this goes to 3/16 plus 3/8 plus 7/16 is equal to 1, because that goes to 1, right? That's 1, that's 1, and that's 1. Okay? So this is 3/16, I should be able to do this in my head, plus 6/16 plus 7/16 equals to 1, and that I can see is true. QED. Boom. Okay. So, we would say then that this is normalized. And that was part A. Okay. Hopefully the shorter video for part B.